pointers in C++. Pointers in C++ or C, both are almost same. Okay, logic is very simple. I will just quickly give some basics, and then we will go into some programming or some debugging kind of question to understand it much better. So you have a variable int x equal to 10. Immediately when I write this, you have to draw a box like this. This is actually memory allocation. It has 10. Let some address be 1000. Okay. Now pointer is a variable. Pointer is a integer variable. It is an integer variable which will store address of another variable. So I am creating another variable here like this. The difference between normal variable and pointer variable is we have to use star in front of it, equal to ampersand x. We know ampersand x will give us the address of this variable x. If I write x equal to, if I print x, it gives me 10. If I print ampersand x, it gives me 1000 because the address of the variable x. So I can write it like this. We can write it int star ptr or p equal to ampersand x. It means it will create another variable ptr. In that it will store the address of x, that is 1000. And since this is also a variable, because it has some declaration, it has some data type, it will have some address. It will have some address, right? So we are using a pointer variable to store address of another variable. Okay, so I will we already seen this example when I write int star p1, okay, or when I write char star p2, or when we write float star p3. Okay, when we write these things, int star p1, char star p2, float star p3, see all the p1, p2, p3, p1, p2, p3. Okay, tell me what is the what is the size of p2? Can someone tell me what is the answer for this? I hope you are aware of this size of function. We have some function size of. Can you tell me what is this answer, size of p2? Size of p2. And same another question, size of star p2. Size of gives how much memory is allocated for that variable. So tell me what is the value of size of p2 and what is the output of size of star p2, right? See here, be very careful. Again, I'll repeat here, p1 is a pointer variable. How I am saying that? Because there is a star symbol. P1 is a pointer variable. What is the use of this pointer variable P1? P1 is a pointer variable. It is used to store address of another variable. What is that another variable? That another variable's data type is int. Okay, it means P1 is always holding an address. It is always holding, P1's box contains address, and that address is of type always integer. Okay, right? This address belongs to which kind of variable? That is this int. Okay, if you see this statement, char star p2. Okay, char star p2. So what is this? P2 is a pointer variable. Okay, with this star I understood it is a pointer variable, right? So P2 will store some address, and this box contains some value that is of type integer only, because address is always integer. Okay, so P2 is a pointer variable which stores address of another character variable. A character variable's address is stored in pointer. So when you say what does P2 contains? P2 contains address. So when you use size of P2, P2's box contains address of type integer. So size of P2 will give me 4. Size of P2 will give me 4. Now what is size of star P2? So P2 is containing address of a character variable. So where is this location 1000? Somewhere here there is location 1000. What does it contains? It contains small character a. Small a, character small a, right? So what is size of star P2? That is 1, whereas size of P2 is 4. Okay, next one, see this last one, float star P3. What does it means? P3 is a pointer variable. It means it will store some address. Address will be of type integer. This address, this integer address belongs to a floating point variable. That address belongs to a floating point variable. That is the meaning of this P3. P3 is an integer. That's why I say, when somebody asks me what is this double star P4, the meaning of this statement is P4 is a integer pointer variable which stores address of a double variable. P4 is a integer pointer variable which stores address of a double variable. So that's why size of, if I have int star P1 char star P2 float star P3, size of P1, size of P2, size of P3 and P4, everything is 4 or the integer size. Okay, why? Because P1 is holding address. Address is always integer. P2 is holding address. That's always integer. P3 is also holding address. The address belongs to different data type variables. Okay, right? I hope this is clear. So this is a little about pointers. Let's see the next thing. So this way we can do that. Now double pointer. What is double pointer? I can create a variable int x equal to 10, and I can create a pointer star p1 equal to ampersand x. I am storing address of x in star p1 variable. Like this, I can create a double pointer, double star p2 equal to ampersand p1. It means I am storing the address of P1 variable into P2. So diagram something is looks like this. You have X with you, it is 10, there is some address 1000. Okay, then you have P1, it stores this address here. So 1000 is there here. Okay, since this is also another variable, see, it's a variable. P2 is a pointer variable. When we say variable, memory allocation happens. So this is 2000. Then again, there is another variable. So P2 is another variable. You can have 2000 in this. Since this is also a variable, it will have some memory allocation like this. Okay, so now you want to print 10, you can either use P1 or P2. How to use P1? If you want to use P1, you have to write star P1. This will give you 10. If you want to use P2, you have to write double star P2. It will give you 20. Okay, like this you can. So one very popular interview question. So can I write like this, int 3 stars P3 equal to ampersand P2? I can do this like this. Can I write something like this, int so on 100 stars P100? Okay, 100 stars P100 equal to ampersand P99. Can I write like this? Can we extend pointers? Can we express like this? Can I have 3 pointers star triple star P3 equal to ampersand P2? Can I have 4 star P4 equal to ampersand P3? Like this, can I keep going it? Can I have 100 stars P100 equal to ampersand P99? How long can I go? Can we write like this, or is there any limitation on this? Just give a guess. Please give a guess. Can we extend pointers like this? Can you extend like this pointers, double star P2, triple star P3, then 4 stars P4 and so on? Okay, right? See, this is not 10, this is 10, sorry. Double star P2 is 10. P1 star of P1 is pointing 10. Double star of P2 will also point to 10. This is not 20, it is 10. So the question which I am asking here is that you can write pointer like this, star P1 equal to ampersand X, or you can extend it like this by creating double pointer P2 equal to ampersand P1, or else you can extend it more by writing triple star P3 equal to ampersand P2. You can also write int star 4 stars P4 equal to ampersand P3. How long can we extend? Please tell. Students, please answer this. Can we extend it like this? How long can we go? Is there any limit on this? Just give a guess. Yes, please. No? No idea? I'm expecting some response. Students, yeah, somebody at least answered. See, when you are extending this way, there is no limit. There is no limit in extending it like this. Okay, you can go as long as you want, you can extend it. And the next interesting concept here is pointer arithmetic. Pointer arithmetic. Okay, so this, I think I have slides about this. Same thing what we have been seeing. Yeah, pointer arithmetic. So what is this pointer arithmetic? Let's understand this. We'll come back to this example problem here. Okay, see, I'm having int star p1 equal to ampersand x. So I already have int x equal to 10. So what is the memory block here? X will have 10, it contains 1000, and p1 will have 1000. Its address is 2000. This way it is mapped. Okay, now okay, so now if you see here, in this case x is 10, p1 is having address of x is stored in p1, that is 1000, right? So tell me the outputs. If I write C out of x, then C out of ampersand x, C out of p1, C out ampersand p1, C out of star p1. Can you guess the answers? Some of them are directly available. So C out of x will be 10 directly. That is very simple. C out of ampersand x will be address of x, that is 1000. C out of p1, can you tell me what will p1 come? When I write third one, C out of p1, what is the answer? C out of p1. C out of p1 is 1000, because see, when you say C out of x, whatever is there inside the box x, whatever is there inside the box x, that content is printed. Same way, when you say C out of p1, whatever is there in the box of p1, this content is printed, that is 1000. And when you print ampersand p1, this p1 variable's address, that is 2000, will be printed. And the last one, star p1. Star p1 means, what is, now how to decode this? How to decode this? It is star of p1. What is p1 value? 1000. So it means star of 1000. The meaning of star of 1000 is value at the address. Value at the address. Value at the address 1000. So where in this computer RAM, in this RAM memory, where is the address 1000? Here. What is the value inside it? 10. So therefore star p1 will give you 10. Star p1 will give you 10. This is the basic understanding about the pointers. Now I am talking about pointer arithmetic. So x is there, it has 10, address is 1000, and p1 is there, it is storing 1000, its address is 2000. Now C out of, or let's ignore C out, I am writing p1 plus plus. Okay, I am writing p1 plus plus. What will happen with this statement p1 plus plus? Which value will change when you write p1 plus plus? I hope you are aware of this increment operator, post or pre. Since it is standalone statement, whether it is pre or post, we have to increment it because it's standalone. Why it is called standalone? This is not linked with some variable like this. It is written independently like this, P1 plus plus. What will happen with this P1 plus plus? Whatever content it is there inside P1, it will take that P1. This meaning is P1 plus 1. Its meaning is P1 plus 1. Okay. So what is this P1? P1 is an address. Right. P1 is a address. Okay. So in this address, P1 is an address. So it is 1000. When you write 1000 plus 1, so you're trying to add address plus a constant. Address plus a constant. When you do this, it will actually move to the next block. It will actually move to the next memory block. So address is 2000. P1 contains 1000, right? Sorry. So here it is 1000 plus 1 means 1 into what is the size of this block? 4. So this will move to 1004. It will move to 1004. So because of this P1 plus plus, this value inside P1, which is 1000, will become now 1004. It will become 1004. Okay. So the meaning here is that the point is that on a pointer, you can perform addition operation like this, P1 plus some constant, or you can also perform P1 plus plus. You can also perform post increment, pre increment. This is allowed. So addition operation is allowed. How addition operation is allowed? With P1 and a constant, you can do addition operation. Let's come to subtraction. Same case, you have x here, 10, address is 1000, and you have P1, it contains 1000, and address is 2000. This is the linkage. Now if I write minus minus P1, okay, if I write minus minus P1, this is a pre-decrement statement. Whatever content is there in P1, take it, subtract 1 from that. So its meaning is like this, P1 minus 1. So address minus a constant when you are doing, what will happen here? 1000 minus 1 means it will add 4. So this becomes 996. It will go to its previous memory allocation. It will go to its previous memory allocation. Okay. So we can perform subtraction also. So this is allowed. P1 with a constant is allowed. So if you summarize the pointer arithmetic, pointer, okay, pointer or address plus or minus constant. Okay, this is allowed. Pointer plus a constant, pointer minus a constant, we can do. Let's see something else. I have P1 with x only I will come. X has 10, address is 1000. P1 has again same example, 1000, its address is 2000. I have y with value 20 and its address is 3000, and P2 is another pointer, it is storing 3000, let this address be 4000. Okay, so I have two variables and two pointers. I have variable x comma y, I have two pointers P1 comma star P2. Now can you tell me what is the output of P1 plus P2? What is the output of P1 plus P2? Please be interactive. Please learn this pointer arithmetic. There are very important questions they ask you in interviews or some coding competitions based on pointers. Don't feel it as difficult. See it as mathematics, only number game. Right? So please, can you guess? Same thing. I understand your point. You are saying the address is in hexadecimal format. It depends on the operating system and the compiler which you are using. Okay, so for easy understanding only, I am randomly choosing numbers as 1000, 2000. But actually, addresses are not 1000, 2000. Just to make you understand how pointers works. For that only, we are giving some simple numbers 1000, 2000. But actually speaking, addresses are in hexadecimal format only. Addresses are in hexadecimal format only. So we are not worried about the address. Some system might give some address, some other compiler, some other system might give some other address. They have their own addressing schemes. Okay, but for easy understanding, we are having that. Okay, that's what I'm talking. See, when you say somebody is asking me pointer 1 plus 1, p1 plus 1. So p1 can be any number. Let it be any type of number. If it is a decimal number, address is 1000, for example, it's an address. It has some tag, address tag. Plus 1 means move to its next block. So what was this block? It was of integer. So 1 into 4 I have to do. So this moves to 1004. So when there is some hexadecimal format, maybe AA, BE, E I have. This is my address allocated for me. Plus 4 means it will go to next block. Actually, it will not add 4. Systems, okay, since this point has come, sorry, I am just deviating. We will talk about this P1 plus P2 later. We'll see this. See, when integer address is allocated, some address like 1402968, when this kind of address is allocated, it means it's a 32-bit machine. It's a 32-bit machine. So it will add plus 4 to it. When hexadecimal address is allocated, it means that particular compiler is using 64-bit machine. I hope you are aware of this 32-bit and 64-bit. We will see this addition also, right? So I'll just quickly erase this. Now tell me, what is the value of P1 plus P2? Assuming the addresses are 1000. Now tell me, before you go for this, you should tell me, if I write C out of P1, what will I get as the answer? If I write C out of P1, what will I get as the answer? Please tell. If we write C out of P1, what we will get? Right, address 1000. Very good. Now this is 1000 plus P2 means, again, C out of P2 means P2 will give you 3000. Right. Okay. So one important principle here in pointer arithmetic is, with a address you can add only constants. You cannot add two different addresses. It is meaningless operation. Between two pointers, we cannot perform addition operation. It's meaning. Let us go into RAM now. Let us go little about RAM and come back. See, this is my RAM of your system. P1, this P1 was stored somewhere here like this. I'm just for easy understanding, I'm drawing this. Please try to understand. So I'm having P1 here, address 1000. Okay, it is storing address. Means X is somewhere here. This location is 1000 actually, and its name is X. It contains 10. Okay, Y is somewhere here. With value 20. Address is 3000. Okay, and assume somewhere here P2 is declared. So its address is, it contains 3000, and this is the location address 4000. Now see, I am saying P1 plus P2. P1 plus P2 means 1000 means this address, this location plus this location. What will I add? It does not make any sense. Adding two addresses. Like better example to understand this, in your street. Okay, in your line, in your street like this. Here we have houses. H1. This is house 2. This is house 3. Like this, we have so many houses. Okay, this house, your house has some address, right? It has some address, pin code number, door number. We know that. Okay, so assume this H1 address, house address is something like this, 4-2-11. Okay, and H3 address is something like this, 4-2-13. Can you find out something by adding these two addresses? No, it's illogical. We cannot add these two addresses. Okay, so between two pointers, we cannot perform addition operation. We can perform addition operation with a pointer plus a constant. We can do the addition. Why? Because now you tell this. this example. See, house 1 H1 address is 4-2-11. If I say add 2 to this, it means move 2 houses next to this house, go one house right, then another house right. So you can say by adding a constant, it is reaching to 4-2-13 house. It is like saying that from this house address, from this H1's house address, go 2 houses. After 2 houses, third house is my house. If I want to say like that, my home, right? Then this is meaningful. But adding 2 different addresses is meaningless. Okay, so I hope you understood about pointer arithmetic, right? Now let us talk about P1 minus P2. P1 minus P2. P1 minus P2. Can we subtract 2 different addresses? Tell me, can we subtract 2 different addresses? If yes, what is the answer? P1 minus P2 can we do? P1 minus P2 can we do? Is my question. Any rough guess? Can we perform subtraction? Okay, let's try to understand this. Okay, see, same diagram, this block you focus on. This is our RAM, same memory allocation. Address 1000 is here, address 3000 is here. You can perform subtraction between 2 different pointers. The meaning of that is how much memory is there between these 2 addresses. Okay, how much memory blocks are there in between these 2 addresses? Or you come to this example of houses, our general example. If I say, what is the difference between address house H1 and address house H3, 4-2-13? Difference means how many blocks are there between these 2? How many houses are there between these 2? Okay, that is meaningful again. In pointer's perspective, between 2 houses, how many houses are there? That you can easily identify. Somebody tells their house address is 4-11. Somebody tells they are in the same street. I am in the same street with house number 17. It means when you know this is your friend's home, from here you have to go 6 houses you have to cross to reach your friend's home. Okay, from one home you have to cross this. You are able to tell. How are you able to tell? You are calculating the difference between the addresses. You are calculating the difference between the addresses. Therefore, the summary here is that pointer plus a constant allowed, pointer minus a constant allowed. Okay, pointer multiplication with a constant not allowed, pointer with the division with a constant not allowed. Okay, so these 2 are allowed, pointer with a constant. Then between 2 pointers, P1 minus P2 is possible, but P1 plus P2 and P1 into P2, P1 divided by P2, these things are not allowed. Okay, I hope you understood pointer arithmetic. Lot of debugging questions, even in GATE exam, they appear with these concepts of pointer arithmetic. Okay, we have lot of questions in internet. Please go through them, try to answer. You may simply, to understand well about pointers, you want good set of questions, you type GATE previous questions on pointers, you will easily get them. You will get so many exercise problems and you will become more familiar with this concept of pointers. Okay, so this is about pointer arithmetic. I hope it is clear. Till now, is it clear? Yes, is it clear till now? Students, is it clear? Any doubts till now in pointer? Yeah, we will see. Uh, So for this problem which we have seen, P1 contains 1000. Again, it has address 2000. We have variable X which contains 10, address is 1000, and P2 contains maybe Y variable is there. It contains 20, its address is 3000. Here it is 3000, and we have 4000 here, right? So P1 minus P2 or P2 minus P1, what is the value? Okay, how to find out the difference between two pointers? See, X and Y are integer variables here. Okay, how do you find out? Find out the absolute difference between P1 and P2. P1 means how much? 1000. So 1000 minus P2 means how much? 3000. 3000. So what is the difference between this? 2000. Absolute difference. Absolute difference means minus will also become positive. So it is 2000. 2000, that is the absolute difference. Divide it by size of the integer, that is 4. So this answer is 500. Okay, answer here is 500. Difference between the pointers, the value is 500, because it means there are 500 integer blocks between P1 and P2, or there are 500 integer blocks between 1000 and 3000. Is it clear? Difference between two pointers. Right. Okay. So a little there is lot of exercise problems are available. We will see these pointers. Let us go and quickly summarize what we have seen. Pointers. So pointers are symbolic representations of addresses. We store address in pointers. What is the syntax here? You can create like this. You can write it int star ptr. You can declare it like this. Then you can write ptr equal to ampersand variable. Or in a single line also you can give it int star ptr equal to ampersand variable. This way also we can give, or in this way also you can declare it. Okay, so this is just an example to understand it. It's very easy, you can answer it. Pointer arithmetic. See, you can perform increment, you can perform decrement, you can an integer may be added to a pointer, an integer may be subtracted from a pointer, and a difference between two pointers. Okay, and a difference between two pointers. These things are allowed. We have just now seen. And generally, there is one note: pointer arithmetic is meaningless unless performed on arrays. We will see this. Okay, let's see an example here. Right. So I'm having v of 3 equal to 10, 100, 200. I'm creating star ptr equal to v. It means I have an array with me with three values, that is 10, 100 and 200. Let the addresses be something like this: 6000, 6004 and 6008. This is the variable v. Now I have a pointer variable star ptr, means I have a variable ptr. I am storing what I am storing: ptr equal to v. Why I did not give ampersand v here? Because it is the name of the array. When it is array, you need not give ampersand symbol. When it is array, you need not give ampersand symbol. You can directly give v. Why? When you write C out of v, if you give like this, it will give you 6000. The starting address of that block will be given as output. So it contains 6000. Okay. Now there are some questions here. For I0, I less than 3, I plus plus, value at ptr equal to ptr. So what is there in ptr? What is the first cout statement? What is the first cout statement? Value at ptr. What we will get as the output? Cout value at ptr and pt. I am printing ptr. What is the output? What is the output? Can you guess the output? When I run this for loop, cout value at ptr. What is the value of this ptr? Yes, please. Okay, right. It will give you 6000. Okay, in the first iteration, it will give you 6000. Then value at star ptr means star 6000. What is there at 6000? Where is the address 6000? Here. What is there in that? 10. So first time 10. Then you see I am writing here PTR plus plus. Right? We are writing here PTR plus plus, means whatever is there inside this PTR box, take it, add. For this, add what you have to add. The meaning of this PTR plus plus means 6000 plus 1. This is one address. Address plus a constant. Address plus a constant means it will go to the next block. So this big 6000 becomes 6004. Now again, value at PTR is 6004 and star PTR is 100. Like that, it will increment. This 6004 will become 6008. Okay. So pointer address plus a constant is allowed. Right. So this is simple example explaining you what it works like. If you want, we can see multiple examples. Next, pointer to pointer, we have already seen double pointer. I have char A, char star B, char double star C. Triple pointer, I am creating 3 different pointers. So I am having A, which contains alphabet G. Then I am having B, which stores address of G. This address is 100. The address of G is stored here in B. Okay. The address of this G or the alphabet A is stored here this way. Then I have another variable C, which stores address of this B, that is 200. This 200 comes here. So pointer to pointers means that extends double pointer, triple pointer, and so on. Okay, it looks something like this. Pointer notations. One very important slide. Lot of gate questions or competitive exam questions or placement level questions come from this one. This has lot of content to understand. Okay, see, you are having a matrix with you. You are having a 2-dimensional array with you. How it is looking like 16, 18, 20, 25, 26, 27. This is your matrix. Okay. This is the input data. Now, indexing, this is 0, 1, this is 0, 1, 2. Okay. Let's try to decode this. This slide you understand much about the pointer with arrays. Please pay attention. I request you all to please listen it nicely so that you understand it. There are a lot of questions dependent on this concept. Now, in general, we know array of ij means array A of ij. Meaning is star of A plus I plus j. That is the meaning of this. Star of A plus I plus j. Let's try to decode this numerically. Okay. Yeah. See, double star num. Now suppose num 0 0. Num I will say it as A 0 0. A 0 0. What is the pointer notation of this concept? You see, double star num means star of num. What does num contain? Suppose the address is 100. This is 104. This is 108. This is 112, 116, and 120. Now tell me, we know that A of 0 0 means 16. By seeing this box, you will tell answer is 16. But through pointer representation, how does it works? That is very important to understand. Okay, so here you see num star of num. So what is num? Now what will this print when I give num? Okay, what is if I write cout for this given instruction? If I print cout of num, what can be the answer for this cout of num? Okay, when you write cout of num here, it will give you the starting address, that is 100. It will give the starting address 100. What is star of 100? Is 16. What is star of 16? No, that's what in two-dimensional array, star of num or star of num both will give you answer as 16. Okay, whether it is star of num or directly star of num, both will give you 16. Why? Because because the meaning of this num here, since it's a two-dimensional array, the meaning of this num is address of this entire block. Address of this entire block. Starting address of this block is there in num. So num indicates this entire box address. Star num indicates this box address. In that star of that indicates 16. Okay, that's why double star num in a two-dimensional array will give you 16. Don't get confused whether you write cout of num or you write cout of star num or you give double star num. Num will give you 100, star num, double star num this will also give you 100. Star num will also give you 100. Double star num will give you 16. Be careful with this array. You will understand it much better when you play the other examples. When you see the other examples, you will understand it better. Right. See here, I have star of star nums plus 1. Let us decode it slowly. What is nums value? 100. What is star of nums value? Again 100. Star of nums is also 100. 100 plus 1 goes to 104. 100 plus 1 goes to 104. This final star of 104 means value at 104, that is 18. Its value is 18. That's why you have to decode it. Okay, let us see. The other things are very easy. Let's see the examples. Let me erase this. See this. Let us see this case. Okay, star of nums plus 1 plus 1. Okay, right. Let's see what is this. Let's try to decode what is this star of nums plus 1 plus 1. This example. Nums is 100 starting address, right? Nums plus 1. Nums plus 1. See, that's what I remember. When we discussed data structures of array, we saw that when I write num plus 1, it will go to this location. It will come to this location. It means this nums plus 1 will give me 112. It will give me 112, or starting address of this block. It will give me starting address of this block. This is the first block. This is the num plus 1 block. Okay, the second rectangle is the num plus 1 block, right? So this num plus 1 will give you the starting address of that. Star of 112 again, star of this will again give you 112. Star of this will also give you 112. 112 plus 1 means I have to go to next block, that is 116. Now what is star of 116? Star of 116 means 26. So this is 26. Okay, let me repeat once again. Let us see this another example for the same case. Okay, let me erase this. Right. So you have 104 here. This is your matrix. Here you see the last case. Let's decode this last one. That is star of nums plus 1 plus 2 plus 2. See, nums is pointing to this. I will change the color. Let's take this nums nums. This name of the array, it is pointing to this block. It is pointing to this block. Num plus 1 will point to this block, the starting address of this second block. Num plus 1 will point to this second block, like this. Okay, now star of that means the starting address of this block, that is 112 plus 2. Address plus 2 means go to 2 locations. So 112 go to 1, then go to second location. So it means this becomes 120. Now, what is this final star of 120? Value at address 120, that is 27. Okay, this is how two-dimensional array with pointers works. It is confusing. You are required to study more number of exercise problems to understand it better. I hope you understood how this is working. The meaning is different. Num is pointing to this entire block. Num plus 1 is pointing to this entire block. Okay, so in two-dimensional array, the address of this, the starting address of this rectangle, the second rectangle is stored. That's why num plus 1 will, star of num plus 1 will give you 120. Okay, I hope it is clear. Any doubts in this? Is it clear how this is working? Pointer arithmetic, pointer notations with two-dimensional array. Very important. We will see more exercise problems if time permits. We will try to see. Okay, just so we will come back to this point. So with this, we will close this pointer notation. We will discuss more exercise problems on the same concept, pointer notation.